So now we'll move on towards the property diagrams for phase change processes. We'll see how these diagram changes uh, as you change or vary one of the parameter. So the variation of properties during phase change process, they are best studied and understood with the help of property diagrams such as TV and PV diagrams for pure substances. So we'll try to first develop a complete diagram, TV diagram for a pure substance which is water, based on what we have understood so far. So the phase change process of water at 1 atmospheric pressure represented on a TV diagram is shown as below. This is the diagram. Now this is compressed liquid region, saturated mixture region, and superheated vapor region. But all of this is being done at constant pressure, which is 1 atmospheric. We'll try to assess what would happen if we change or if we repeat the process at a different pressure. That would help us develop the complete TV diagram. Let's say we add weights on top of the piston that we had, until the pressure in the cylinder reaches to 1 megapascal. So we'll try to develop the same diagram at 1 megapascal. At 1 megapascal, do you expect uh, the specific volume to be more or less as compared to that at state 1?
Less.
All right, very good. So one thing is that at 1 megapascal, water would have a smaller specific volume than it does at the 1 atmospheric pressure. Secondly, if I say that the pressure is 1 megapascal, do you expect the or let's look at this way, at let's say 1 atm pressure, the saturation temperature was what?
100 degrees centigrade.
100 degrees, sir.
100 degrees centigrade. For 1 megapascal pressure, do you expect that the saturation temperature would be high or it should be
High,
low?
sir.
Very good.
High,
So
sir.
this would be high as compared to 1 atmospheric. That means this horizontal line at 1 megapascal, the horizontal line, which is the saturation, should it go up or should it move downwards?
Upward, sir.
So it should move upwards. That is the second thing that you observe. Another thing is Another thing is that it is said that at the heat as the heat is transferred to water at this new pressure of 1 megapascal, the process that follows is very much like the process at 1 atmospheric pressure, but there are some noticeable differences in the process. One, you have already seen that the specific volume at state 1 would be less. The other is that the saturation temperature, T saturation, would be higher. That means this line would move upwards. Other differences, so as it says that water starts boiling at much higher temperature, which is 179.9 degrees centigrade. So T saturation is 179.9 degrees centigrade. The second thing is the specific volume of the saturated liquid is larger. Which state is the saturated liquid state in this line? The line shown to you in 1 atmospheric line. Which state is the saturated liquid state?
2, sir.
Very good. So for 1 megapascal, it says that the saturated liquid, the specific volume, that means this value would be larger. This means this point should move to the right or to the left.
Right, sir.
Sorry, who says left? If your specific volume is larger, it should move to the right hand side. That means to this side. And the saturated vapor is smaller than the corresponding value at 1 atmospheric pressure. So that means the point 4 should move inwards. Is it so?
Yes, sir.
So you will have the new point for 1 atmospheric pressure, 1 megapascal.
Hello.
You have 2 bar over here and let's say 4 bar over here. That means the line of phase transformation would be shorter horizontal line. Is this point clear to you?
Yes, sir.
All right. This means that as I increase the pressure, as the pressure is increased further, the saturation line continues to shrink until it becomes a point where the pressure reaches to 22.606 megapascals. So as you continue increasing the pressure, these 2 points would coincide at a point. That means the point would come and meet at one point for the pressure which is 22.06 megapascal, and this pressure is known as the critical point. So when the saturated liquid and saturated vapor states become identical, they are known as the critical point, and at that point you will not have any distinction between the compressed liquid and superheated vapor in form of a mixed region. Clear enough?
Yes.
Yes, sir.
सर
सर सर
जी
उस
जी जी
पॉइंट उस पॉइंट पे फिर सर उस पॉइंट पे फिर सप्लीमेशन स्टार्ट हो जाएगी.
sublimation. Where do these, how come you're defining the behavior of liquid to gaseous phase transformation? Sublimation involves
सॉरी
what?
सर मैंने वर्ड 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 मैंने रॉन्ग यूज कर दी. एक्चुअली मैं जानना चाह रहा था कि फिर सॉलिड डायरेक्टली गैसेस में चेंज होगा.
Sublimation is that solid converting into gas, but where is the solid coming from? You are talking about which phase transformation? This is basically liquid, this is basically vapor. So you are talking about liquid to vapor phase transformation. In between the liquid to vapor phase transformation, you have a mixed zone where you have liquid and vapor coexisting. At this point, there is no fixed mixed zone that differentiates the two regions.
ओके सर.
Alright, sublimation to solid के साथ involved है. Solid, you are not discussing the solid phase transformation over here.
तो सर वो मैं थोड़ा सा कंफ्यूज हो गया था. मैंने टर्म यूज गलत कर दिया.
Alright.
सर
So,
इस केस में
जी
एक्सक्यूज मी
जी
सर इस केस
जी
में सैचुरेटेड मिक्सचर फिर खत्म ही हो जाएगा सर. कंप्रेस्ड लिक्विड डायरेक्ट वेपर में कन्वर्ट हो जाएगा.
compressed liquid. We'll see how we'll define this. We'll see how we'll define this. Just give me a
सर
minute.
ये क्रिटिकल पॉइंट जरा एक बार बता देंगे दोबारा.
I'm coming to that. I'm coming to that. It would be repeated again. Don't worry. This point, is this point clear that this line is for, let's say, uh, zero point 0.1 megapascal? That means 101 kilopascal or 1 atmospheric. If this is the line, for 1 megapascal, the line would be higher. Is this clear? Is this point clear?
Yes, sir.
Yes, sir.
All right. Now, if you see, these are the saturated liquid points, these are the saturated vapor points. If I continue increasing the pressure, you see that this line is shrinking. These 2 points are getting close together. Saturated liquid and saturated vapor points are coming close together as I am increasing the pressure from zero point 0.1 megapascal to 8 megapascal. Clear enough? Is it
Yes,
clear
sir.
so far? Now, if I continue increasing the pressure, let's say to 15 megapascal to 22.06 megapascal, what would happen at 22.06 megapascal? There is no distinct two-phase region existing. There's only a point. This point is the critical point, and what you'll do is that this is the critical temperature, correspondingly critical specific volume along this line, or for any line which is beyond this line. Let's say this line. For this line, below the critical temperatures, you would have compressed liquid, and above this line, above this temperature, you would have, for this purple line, you would have superheated vapor phase.
Vapor.
Clear?
Yes, sir.
All right. So again, this is shown to you. Okay, when you have pressures less than critical pressure, you have a distinct phase change process taking place. At critical point, this process is just taking place across a point. Above that, you have no distinction between the phases. So number one, you define the temperature, pressure, and specific volume corresponding to the critical point as critical temperature, critical pressure, and critical specific volume. At pressures above P critical, there is not a distinct phase change process taking place. Instead, the specific volume of the substance, it continues to increase indefinitely. And above the critical state, there is no line. Above the critical state, there is no line that separates the compressed liquid and superheated vapor region. Superheated vapor region is basically for temperatures above the T critical, and compressed liquid for the temperatures below the T critical. So for this line, the last line, up till this point, for temperatures less than this, you will have compressed liquid. For temperatures greater than this temperature, which is this line, you'll have superheated vapor phase. Clear enough? Is the
Yes, sir.
point clear? No. All right. Moving on. Now let's say I have this temperature and specific volume curve, and these are the different pressure lines for the uh, change in temperature and specific volume. Let's say I take this point, this point, this point, this point. I use these points. So these are which points? Saturated liquid and saturated vapor points.
Yes, sir.
And if I try to join these points by this line, what would essentially I have? I would have a line which is the saturated liquid line. This line would be my saturated liquid line. I would have a saturated vapor line. So this line would be my saturated vapor line. I would have a critical point over here. This would be my critical point. This region would be what? This would be the compressed liquid region. This would be very good. The region to the right would be the superheated vapor region, and this central region would be what? This is the saturated liquid.
Saturated mixture.
Yes, saturated liquid vapor region, or this is also known as wet region. And for this, I would have this line is what? This green line is what line?
सर ये सैचुरेटेड लाइन है.
सर मिक्सचर है सैचुरेटेड और लिक्विड और वेपर का.
The complete line. इसको क्या कहेंगे?
Phase change at 1 atmosphere.
What is happening to pressure on this line?
सर सैचुरेटेड मिक्सचर कहेंगे ना.
Constant pressure.
Constant pressure.
So this line is basically the constant pressure line. All right. So at this line, it is the P1 equals to constant. And if I have another line, which is this line, this would again be a constant pressure line, and this pressure P2 should be less than P1. All
Greater
right.
than.
It should be greater than. Very good. This should be greater than P1. All right. So this is a constant pressure line, and it is P2 is greater than P1. Clear enough? So far, is it clear?
Yes, sir.
Yes, sir. Yes, sir.
All right. Again, the same is repeated over here or shown over here. It says that you have the saturated liquid states connected by a line called the saturated liquid line. So this line basically represents the saturated liquid states, and the saturated vapor states are connected by the saturated vapor line, this line, and they meet at critical points. So the two lines, they basically meet at the critical point, forming a dome. A region to the left of the saturated liquid line is basically the compressed liquid region, and to the right of saturated vapor line, region to the right of saturated vapor line is basically the superheated vapor region. And in these two regions, the substance exists in a single phase. Either it exists as a liquid or it exists as vapor. And all the states that involve both the phases in equilibrium are located under the dome, and these are called saturated liquid vapor mixture region or wet region. Is this point clear? Are there any questions so far regarding what we have covered?
क्लियर है सर.
All right, great. So moving on, we have seen the temperature specific volume diagram or the dome. Now we need to understand how does this diagram, how is this diagram different from the pressure volume diagram, pressure specific volume diagram. So let's start with the process. It says that the general shape of the PV diagram of a pure substance is very much like the TV diagram, but it has a downward trend for constant temperature lines. In T specific volume diagrams, you had constant pressure lines. All right. In pressure specific
Yes, sir.
volume diagrams, you would essentially be having constant temperature lines. All right.
Temperature.
Very good. So it says now consider again a piston cylinder device that contains liquid water at 1 megapascal and 150 degrees centigrade. Water at this state is basically compressed liquid. All right. If I have to Right, all right, we'll come to it later on, but let's stick to this. All right. So you have this piston cylinder with you, in which there are certain weights on top of a piston, and you have liquid water which is at 1 megapascal and temperature is 150 degrees centigrade. Now, if I remove this one block, if I remove this block from this uh, piston, what would happen to the pressure?
Pressure decreases.
Decrease कर जाएगा.
It's decrease.
Pressure would decrease. Or in other words, what would happen to the specific volume?
Increase.
Increase culture. The specific volume would increase. Now, uh, as the specific volume would increase, this system would do some work. All right.
Yes, sir.
Now, if the system is doing work, what would happen to the temperature?
Decrease.
It would decrease, but
Constant.
sorry, sorry.
Temperature will tend to decrease.
Yes, the temperature would decrease, but the same amount of the heat would be taken up by the system from the heat. So it's given to you. The temperature would essentially remain the same. All right. Is it clear?
Yes, sir.
All right. So if you remember the temperature specific volume diagram, in those cases, if you increase the temperature, your specific volume was increasing. But in the case of pressure, you are decreasing the pressure and your specific volume is increasing. Clear?
Yes, sir.
All right. So you continue decreasing the pressure and your specific volume continue to increase. If my temperature is fixed, let's say the temperature is 150 degrees centigrade. This temperature would have some saturation pressure.
Of course, sir.
Yes.
G.
Of course, sir. होगा, sir.
G. All right. So once you're decreasing the pressure and your pressure reaches to the saturation pressure, let's say for your case the saturation pressure is 0.4762 megapascal. So if you are decreasing the pressure from 1 megapascal, you are decreasing the pressure to 0.4762 megapascal. As you have decreased, your specific volume has increased. This is the saturation pressure at 150 degrees centigrade. What would happen at this pressure?
Liquid start evaporate.
At this pressure, if you keep if you keep the pressure constant at 0.4762 and the temperature is also constant, this heat which is adding into the system, this heat would be utilized to convert liquid into gaseous phase, because this is the saturation pressure. All right.
Yes.
So at 0.4762, the transformation from liquid to gaseous phase would continue until all of the liquid converts into saturated vapors. And after that, if you remove any of this block, the pressure would decrease and your specific volume would continue to increase. Is this point clear to you?
Yes, sir.
Yes.
All right. So how you are decreasing the weight? You're decreasing the pressure by removing the weights from the piston one by one, which results in decrease in pressure inside the cylinder. As a result, the uh, the piston basically expands, and the temperature which decreases is being made up by the heat exchange from the surroundings, which keeps the temperature constant. As the pressure is decreased, the volume increases until the saturation pressure is being reached. So once the saturation pressure has been reached, which for your specified 150 degrees centigrade temperature is 0.4762, the water starts to boil. And if you see, this is the behavior that when you are decreasing the pressure, the specific volume continue to increase until and unless you reach to the saturation temperature, or sorry, you continue decreasing the pressure until your pressure reaches to the P saturation for T1. At T1, at this point, your phase transformation from the liquid to vapor phase would start taking place. Once your process is complete, you would see once the last drop of vapor is vaporized, the further reduction in pressure results in further increase in specific volume. So if you further decrease the pressure, you would see that the specific volume is increasing for this line. Clear enough? Again, when the process is repeated for other temperatures, that is T2, you would see the phase change process would take place in the same manner, and connecting the lines would give you the PV diagram for pure substance. Now remember, this T2 is greater than T1. Why? Because this is corresponding to higher saturation pressure as compared to this pressure. Is the point clear? I'll stop over here